Alright, so this is the simulation that you unfortunately cannot do because it's not going to work on a Chromebook. You could do this on a computer, and if you have access to that, I have provided you the link within the lab. But what I want to show you is the difference between salt and sugar. And this is nice because it's going to show you on, actually let's look at micro first. Sorry. And now we'll shake the salt in there. Alright, this is nice because it shows you on a sub-microscopic level what actually happens to the ions. And if we look at our key, the sodium is the pink, the chloride ion is the green. And what happens with ionic salts that are soluble is that the ions separate from each other, and that is called dissociation. Alright, we're going to reset this, and we're going to pick sugar and look at the difference. By contrast, the sucrose molecule is very, very large. So when sugar dissolves, all of the molecules in the in the crystal separate from each other, but the molecules remain intact, and as you see, they're rather large molecules. So no ions are generated. So now we're going to flip back to macro. And this, unfortunately, does not allow us to see the dissociation of the ions, but it does allow us to do a conductivity test. Actually, let's reset that and test the conductivity prior. All right, if this is distilled water, what happens to my light bulb here? All right, there are little or no ions in solution, so this pathway is broken and the light bulb does not come on. But as soon as we shake the salt in there, and that dissociation occurs and those ions are generated, now those ions, because they're dissolved, not only do they have charges, but they have mobility. They have the ability within the water to move from one electrode to the other electrode, thereby completing that electrical path. And if my concentration of ions grows, you'll see that the light bulb gets brighter as there are more ions to deliver that current. Of course, we're going to max out at the battery strength or the light bulb strength, but there you have it. So now let's look at the sugar. We'll switch it to sugar. We'll test our light bulb. We'll test our water. No light. And you want to test the water at first to see, is your water clean? Because if your water's dirty, then you could have a false positive test. And no dissociation with the sugar, no ions are generated, so I have no light bulb.